All right, next up, a decomposition reaction. So this is notes 10.1 part 2. A decomposition reaction often happens through heating. Binary compounds decompose into elements. Yeah, binary compounds decompose into elements. So what does that mean? Okay, a decomposition reaction is going to have something that looks like this. You're going to have a compound XY, where X and Y represent two different elements. Okay, so for example, sodium chloride might be an example of that. Decomposition reaction is going to have a single arrow, and these two things, X and Y, break apart, yields X plus Y. That's a decomposition reaction. Now this Y could also be a polyatomic ion like sulfate or phosphate. It could be something like that as well. All right, but a decomposition reaction always takes this form right here. XY yields X plus Y. In other words, it breaks apart, it decomposes. So for our example, solid aluminum chloride is heated. Okay, so that's going to look like this. Aluminum chloride, AlCl3, that's aluminum chloride, solid, is heated, and it decomposes. Okay, it decomposes into what? Well, it decomposes into aluminum and chlorine, Cl2. Remember, chlorine's diatomic. Chlorine is diatomic. It would be beneficial for you to go back and memorize what the 7 diatomic elements are. I'll put them at the end of the video, I guess. So aluminum and chlorine. Okay, this also is unbalanced. So we start again with one reactant, we end with several products. It could be more than 2, but the point is that this one reactant breaks up into a few different things. Okay, so this is an unbalanced equation. Aluminum chloride yields aluminum plus chlorine gas if it's heated. The next up is a synthesis or combination reaction, and what you have here is you have several reactants, and they come together and they form one product. So a synthesis reaction would look like this. How could I do that? It could go X plus Y yields product XY. That's a synthesis reaction. Okay, let's go ahead and look at our example. Solid phosphorus and sulfur combine to form tetraphosphorus trisulfide. Okay, so solid phosphorus, P4, solid, plus sulfur, S8. That's nice that they give us the chemical formulas here. These two form tetraphosphorus trisulfide, tetraphosphorus, so P4, trisulfide, S3. Okay, and that's also going to be solid. There you go. That's an example of a synthesis reaction. Let's relate it back to this example here, this general example. You have reactant X plus reactant Y forms this combined compound XY. In this case, it's going to be P4 plus S8 forms P4S3. Again, this is unbalanced. Make sure you write that it's unbalanced. Okay. We're going to teach you how to balance equations later on. It's very fun. Okay, next up, single replacement. Single replacement takes place in an aqueous solution, and a single replacement will look like this. You'll have reactant X plus some reactant YZ. X plus YZ in solution, and then this will change out with that. Okay, so what ends up happening is you get Y plus XZ. So this element will switch out with that element. Okay, pay close attention to this one. So aluminum metal is placed in a solution of zinc chloride to form zinc metal and aqueous aluminum chloride. Pretty cool. So that's going to look like this. Aluminum metal, AlS, is placed in a solution of zinc chloride. Zinc chloride is your XZ. So ZnCl2, aqueous. What happens? Aluminum switches places with zinc to form aluminum chloride, AlCl3. plus zinc metal, Zn. And again, this is unbalanced. Unbalanced, okay? That's a single replacement reaction. Your last is a double replacement reaction. Very similar to a single replacement reaction in that it also takes place in aqueous solution. Here's the difference. You're going to have two compounds in a double replacement. So you go W X plus Y and Z. In a double replacement reaction, what happens is W and Y will switch places. So you end up with YX plus WZ. That's a double replacement reaction. In this case, we've got solutions of lead 2 nitrate. Okay, so lead 2 nitrate is going to look like this. Pb NO32 plus potassium phosphate K3 PO4 yields is mixed and it forms lead 2 phosphate, right? This lead and potassium are going to switch places. See that? Lead and potassium will switch places. So you're going to end up with Pb Pb3 PO42 plus KNO3 potassium nitrate. And again, you have to write that this is unbalanced. Okay, we'll go back in and balance these later on. That right now is unbalanced. Okay, and this is aqueous. Aqueous. This formed a solid. That's aqueous. How do I know that? I look on my solubility table. Now there's a lot going on here. We got solubility table, we got states, it's all starting to come together, okay? We've got polyatomic ions, right? So now it's important that you know what your polyatomic ions are, that you're able to read your solubility table, that you know what your diatomic elements are, and that you understand what your charges are, what the Roman numeral means. So now we're bringing everything that we've learned throughout the entire year, we're bringing it all together. Okay, so it's super, super important that if you're weak in any of these areas, like for example, you don't know what the 7 diatomic elements are, and I'll pull them up right now, one moment. Okay, like I was saying, if you're weak in any of these areas, like for example, you don't remember what your 7 diatomics are, H2, N2, F2, O2, I2, Cl2, Br2, that you go back and brush up. If you're weak in the area of your polyatomic ions, we'll get your polyatomic ions list out so that whenever you do these things, you're able to refer back to those. If you don't remember the difference between nitrate and phosphate, or what else? Yeah, just keep those general things in mind. Get your and your solubility table. You're going to need that as well, and your periodic table. So you're going to need all these things in this upcoming unit. We're going to put it all together here. And of course, if you're feeling overwhelmed, I can help you out with these. All right. And then once you get the hang of them, you're really going to have a good grasp on chemistry and how it works. So we'll go ahead and do worksheet, the worksheet 10.1. And for that, you don't have to write out any of these things, okay? For that, all you have to do is classify these reactions. You look at them and classify them into one of these 5 different categories. Okay, bye-bye.